guess you could look at it that
Or
way.
Taylor-Maclaurin.
I guess you could say it that way. The intro to math literature.
Okay.
So everybody, what about number 13? Let's take a peek at my nth term. Let's see if I can play a quick game of comparison test. Okay, guys, I need some help. If I just get rid of the 1, what direction am I going? This one or this one? Top or bottom?
Neither.
Well, from here to here.
Um,
Yeah, the one on the left is bigger.
Yes.
I agree. What about removing the one downstairs?
it'd be the other way around.
Shoot, if it's the other way, I guess I'm not comparing directly. Darn it, you guys, I'm pounding my fist. I came so close, I'm pounding my fist. Meaning,
Limit comparison.
yeah, meaning limit comparison test. So with the limit comparison test, let me take a peek at the limit
So,
as an increased stop bound, Dave.
because I'm trying to see what your thought process and the pattern, so I can.
And here's my thought process. I was just trying to compare this to something simple like this, which is just this, which is just this. And if I can compare this smoothly from left to right to that, jeepers, that's the nth term of the harmonic series. I know it diverges. So I guess in the end, it'd be nice if I can get my nth term to be at least as big as that nth term. Therefore, by the comparison test, I'm done. Very little work. I like to use a comparison test first because it's easy. Unfortunately, when I try to whittle down to just simply an n squared downstairs, darn it, this denominator is bigger than that one. Therefore, this fraction is smaller than this one since the numerators are the same.
Well,
And it didn't work.
What I'm trying to see is, because you're not really using math in this case. All you're doing is just removing things. So you just took out the 1, took out the 1.
I still think I'm using math in the sense I'm comparing the evaluation of algebra.
True, but you can't just pull out a 1 out of a n plus 1 squared.
I think I can, as long as I make the mathematical statement correct. As long as I make the comparison correct.
Okay.
And you gotta admit, if I succeeded with greater than, greater than that, I think life's easy. Because now I think my particular nth term is bigger than the nth term of the series. I know diverges, therefore by the comparison test, my series would diverge as well.
Well, what I'm saying, if there was 2n plus 3, n plus 4, you can just throw that n plus 1 away as long as you keep the, whatchamacallits, in the right direction, you're fine.
Yes, I agree with that.
Okay.
Although I admit, David, if this happened, and it was consistent, now I think the comparison test would be inconclusive.
Okay.
Because my nth term is less than or equal to the nth term of a series known to diverge, therefore the comparison test is inconclusive. But if I was able to do it the other way around, sheepers, I'd be really happy, less worried.
So since with the limit comparison, well, any of these we can choose whatever we want, can we choose something that has cancellation and has cancellation
Yes.
affect our?
Yes, so can I tell you, if you look online at past exams, not that I have, here's what I'll typically do. I'll give you like 6 series and say, test them. Don't use the same test twice. Just so I can see your thinking. You're not saying, oh, this works for all of them. Okay, so if I take the limit of the ratio of my nth term, this piece right here, to the nth term of another series, I gotta make a decision. What do I compare it to? It's easy. I think this is a rational expression. And so if I blew everything up, upstairs and downstairs, and look, the very first leading term upstairs, that'd be a 2n. Can I suppress a 2? Just n. And the leading term downstairs is n squared. So I get an n over n squared, which is just 1 over. And that's what I'll limit compare to. So a limit compared to 1 over n, but that's just simply going to give you this particular limit. Is that a 2n squared plus n all over an n plus 1 squared, which, by the way, off the top of our heads, values immediately to I said immediately to I do, 2, which is strictly positive. Therefore, since this particular series diverges as a harmonic series, by the limit comparison test, my series diverges as well.
1 over n, that's just, you chose the leading coefficients on that, or the leading n?
Deleting n's, if you want to include the leading coefficients, that's fine, you're gonna get the same answer at the end, I'm just being lazy. I was just looking at the ratio of n to the highest power upstairs to n to the highest power downstairs, suppressing coefficients. If you don't suppress coefficients, your conclusion will be the same. I was just being lazy with my arithmetic. Alright. Ooh, my next one looks monstrous. Yeah, that sounds reasonable. I'm sorry, you guys, I'm really stalling. I don't know what to do with this one. So Sean says, let's compare it to 1 over n to the 3 halves. Well, everybody, these denominators are the same. But this numerator is larger, if I put it in correctly. And so I think the direction of inequality is this one. So question, is this the nth term, if I can make a full sentence? Is this the nth term of a series that converges or diverges? Yeah, I agree it converges, with p being equal to 3 halves, which is bigger than 1, as a p series, it converges. So I guess it's not going in the right direction. Because my nth term being larger than the nth term of a series that converges means the comparison test doesn't apply. Yes?
Do you have to state, like, for which values of n that inequality holds true?
Only if it's not true for all of them. Like in one example I had earlier, where I stipulated, oh, this is only true if n is at least as big as 4. I would have to stipulate that, yes.
Like in this case, if n is equal to 1, then it would not hold true, right?
You know what, you've got a good point. I didn't even see that. I guess if I'm going to make this legal, you've got a good point. Like in my other example, I have to stipulate that n is at least as big as, I don't know, how about 3? That one. When I put them on the board, I didn't even notice that. Since you guys are pounding my fist on the table, it almost worked. Limit comparison test. Are you happy? Are you happy?
No.
When? You shouldn't be happy. No writing. If I take my term, divide it by the other one, I think I end up getting in the limit natural log of n. But what does the natural log of n do as n increases that bound?
It
It increases
diverges.
that bound. So I guess the limit comparison test doesn't apply there. It didn't work. Do you see that? All right, let's try something else.
Integral test?
Oh man, don't give it all away. I was thinking the same thing. But is there anything else I can do with comparison or limit comparison? What about this? What about limit comparing to 1 over n? I mean, that's the nth term of a harmonic series that diverges. What happens when I take a peek at this limit? Let's see what happens. Maybe this will work. I get the limit as n plays this game of the ratio of natural log of n to, I don't know, is that n to the 1 half? And if I employ L'Hopital's rule, I think I get this. But that just simply gives me this. Oh, you guys, is that a 2 over root x? What's that limit value to?
0.
Nice. So what can I conclude?
Nothing.
Absolutely nothing. Because I think this has to be a number L that's strictly positive, and it's not. Or, it could be equal to 0, that's fine. Being equal to 0 is a limit, okay, as long as I was limit comparing to another nth term of a series that converges, shoot, it doesn't. That's the nth term of the harmonic series. Do you guys see I'm struggling? I'm just trying to employ either the comparison or limit comparison test. I think they're fairly easy tests to use. I think I'm exhausting all possibilities. I'm not coming up with anything. I think maybe this is a case where I got an example in which I'd probably rely on the other tools I have available, which is the integral test like suggested. So everybody, suppressing checking things. And I have to confess, if n is equal to 1, the particular function is not positive, but at least it's 0, you guys, it's not negative. So if you don't mind, can you do a little bit of hand waving and look at that improper integral? Can you help me with it? 1 on up of natural log of x to x is a 3/2. You guys, I know I'm running out of time. We don't have to finish this if you want to, but at least we get far enough to where we know if the answer is yes or no. I'll start you off. I'll start you off correctly. Oh, I'm feeling more comfortable. At least now I got it properly. You know the type of integral you're going to be dealing with next week on Tuesday. I was hoping to be more available to talk.
Excited?
Yeah, that too.
So,
Oh, man. Yeah, you could do a natural log of x, u sub maybe? No, that's not going to work.
Yikes.
You'd have to u sub x to the 3/2 maybe? And then you can manipulate the u and...
so 1/x. Split up
That u being equal to x3 has actually looked pretty good. It's just that du kind of gets messed up.
Yeah.
I heard that. That's what I'm thinking. I'm sorry if I can't do that far in my head. That's what I'm thinking. I'm thinking of letting u be the natural log of x. And like I said, you guys, if I'm boring you to death, we don't have to finish. X is this, or sorry, dx I meant. Cheapers. dv is this. But that means du is this in terms of dx. That means v is equal to x to the negative 1/2. Is that times -2? But that means I'm now left with a limit as t plays this game of some stuff, where the stuff is a product of u and v. Is that a negative 2 natural log of x over root x, evaluated from here to here, minus the integral of 2 times, negative 2 times, the product of these two. I don't know, what do you think? Shoot. It works piece of
You
cake.
just integrate that, yeah.
I think we're done. I think when you plug t in for x, if you L'Hopital this real quick, it goes to 0. It does. It really does work nicely. And clearly this improper integral converges as well. What is it converge to? I keep talking about the test next week.
Negative.
Whatever p minus 1, when I put the limit.
2 times 1/3.
Oh, I forgot the 2, I'm sorry. I was just looking at that. But 1, or in this case, 2 over p minus 1, which is 2 over 3/2 minus 1, which is 2 over 1/2, which is 4. So I think clearly this converges. Verified by the integral test, my corresponding series converges as well. I did not realize that was a really good question. That was very slick. Guys, I'm out of time. What am I going to do? Do you want to cite a little bit of homework, or just wait until tomorrow?
Well, couldn't we just
Well, I
go
think
through and do
that's
all
enough.
this?
That's what I was thinking. I really, guys, I keep blowing it in class. I have so much expectations. I'm so ambitious. I think I can get so much farther than I am. I meant to get so far that I can assign exercise almost without chopping up the homework. So do you think I could just wait until tomorrow?
Yeah. Are there solutions for this?
No, but I'll put them in.
Okay.
I'll get that.
Can you talk about the quiz tomorrow?
Yeah, what is the quiz tomorrow? Quizzes, oh, I forgot, yeah. Well, those are take-home though, I can do whatever. And I don't have to tell you now, right? I think you're just worried about the in-class quiz.
Yeah.
I don't know you guys, I just got myself
We
worn
didn't,
out.
we didn't do separable DEs yet.
That we didn't actually do.
You mean on a quiz?
On a quiz, yeah.
Are you guys excited about that?
Yeah.
You made the decision
Sure.
for me. Do you think tomorrow, can we do something different? Only because I'm getting nervous. I hate to cram things down your throat the last week. Can I come in, we'll take a quiz, and then kind of run into some material? Because, I'm free after class every day. I can answer questions.